7.7c homework. So we are going to divide 5 to the 6th by 5 to the 4th. We're going to use the quotient rule, which basically means that if you have the same base and you're dividing, or you have a fraction like this, you're going to take the numerator's exponent and subtract the denominator's exponent. So 5 to the 6th divided by 5 to the 4th is 5 to the 6th minus 4, which means you end up with 5 to the 6th minus 4, or 2. And 5 squared is 25. Now this should make some kind of intuitive sense. So for instance, let's say we had 2 to the 3rd power divided by 2 to the 2nd power. If we extend this without exponent, that would be 2 times 2 times 2 over 2 times 2. And then you would simply cancel out what's left, what matches in the top and the bottom. And in this case, you would just have 1, 2 left over on top, which means your answer would be 2. Right? So wherever you have more of them, that's where you're going to put the leftovers. Okay, so let's try another one. So the next one is x to the 11th divided by x to the understood or implied 1. So we have x to the 11 minus 1, which is just x to the 10th. Next one we see, we have x to the 14th to the 2nd power divided by 14 to the 9th power. And just like I said before, 2 of these on top will cancel out 2 of those on the bottom, leaving you 7 on the bottom. That trick works. But let's say we want to do it the long way. So we say 2 minus 9 is equal to 14, and 2 minus 9 is negative 7. And to get rid of this negative exponent right here, we have to take this entire numerator and put it on the bottom. And we end up with 1 over 14 to the positive 7th power. But again, we kind of would have been able to determine that by saying 2 on top cancels out with 2 on the bottom, leaving me 7 on the bottom. We had more on the bottom, so the leftovers go on the bottom. I'm going to come over here and try this one. We have 12 divided by 6, which is a 2. And then we have 8a to the 9th divided by a to the 2nd. So 9 minus 2 is 7. Next problem we see over here, we have 35 divided by negative 42. We try to determine what we can divide both into a 35 and that we can divide into a 42. We can divide both of these by 7. 35 divided by 7 is a 5. And a positive divided by a negative is a negative, so I'm going to put the negative off here to the middle. And 42 divided by 7 is a 6. And we have n to the 2nd power divided by n to the 3rd power. 2 minus 3 is a negative 1. So we have 5 over 6 and n to the negative 1st power. To get rid of that negative power, we have to put it on the bottom, which means we end up with negative 5 over 6 with the n to the 1st power on the bottom. And you don't even need to put the 1st power. Or you could just think there's 2 n's on top that will cancel out with 2 n's on the bottom, leaving you 1 n on the bottom because you had more n's on the bottom to begin with. All right, let's try the next one. Next one is a negative divided by a negative, so it's going to be a positive. And 15 divided by 3 is a 5. So next we have d to the 2nd on top and a d to the 1st on the bottom. Understood or implied 1 exponent when you don't see it. So we're going to end up having 2 minus 1. And then we have g to the 4th on top. And we have g to the 1st power on the bottom. So we end up having g to the 4 minus 1. Okay. And it doesn't look like we have anything on the bottom right now. So we continue on. So we end up with a 5. D to the 2nd minus 1 is d to the 1st, or just d. G to the 4 minus 1 is g to the 3rd. And there's nothing left in the denominator, so that's all you get. Here we want to divide with a little division bar here. So now we're saying 75 divided by negative 15. So we know the answer is going to be a negative. And 75 divided by 15 is a 5. So we have a to the 3rd over a to the 7th, so it's 3 minus 7. We have b to the 5th over b to the 6th, so it's 5 minus 6. Now, another way of looking at this is 3 of the a's on top will cancel out with 3 a's on the bottom, which will leave you 4 on the bottom. Another way of looking at the b's is we have 5 b's on top and we have 6 b's on the bottom. So 5 b's on top will cancel out with 5 b's on the bottom, leaving me 1 b on the bottom. But let's say we want to do it the long way. So we write it all out. Okay, so at this point we're going to keep a negative number. We have 5. A to the 3 minus 7 is a to the negative 4. And b to the 5 minus 6 is negative 1. And in this case, we have to pull the factors on top with negative exponents to the bottom, which gives us negative 5 over a to the positive 4. It used to be a negative 4, now it's positive 4. B to the positive 1. Used to be a negative 1, now it's a positive 1, but it's understood or implied, so I don't have to write it down. Next, we see the next one. A negative 14 divided by a positive 49. We know the answer is going to be a negative. And I can divide both the numerator and the denominator by 7. So negative 14 divided by 7 is a 2. So we keep the 2. And then 49 divided by 7 is a 7. So we keep the 7. Next, we have s to the 4th on top over an s to the 4th on the bottom. Another way of looking at that is just if you have the same on the top and the bottom, they will just cancel out. And that's just going to be verified. Next, we have t to the 3rd over t to the 7. So we have 3 minus 7 for the next one. Anyways, this is just going to be 4 minus 4 is 0. Anything to the 0th power is 1, and then 1 times anything. So this is just all going to go away. So there's really no reason to write that step. So you keep the negative 2 over a 7. And t, 3 minus 7 is negative 4. And then to get rid of this factor with a negative exponent, we're going to put it on the bottom. And that gives me negative 2. Except now instead of the t to the negative 4th being on top, a t to the positive 4 is going to be on the bottom.